All right, let's start with this first subtopic. And for, for this part, we're going to talk about the definition and evolution of intelligent electronic systems. Okay, so meaning before we can appreciate the actual topic that we have, it's nice that we can we can be in the same page by understanding the one of the use cases of modern communication systems. So why do we have to make it faster? Why do we have to accommodate more, and so on? Okay, why do we have to keep our communication systems evolving? Because actually we can what with what we have right now we have already met the minimum requirements that we have. We get to talk to someone from the other part of the world, someone from over seven seas, someone from different continents, or someone from just a few blocks away. We can conveniently talk with them, get connected with them, whether via voice, via text, via multimedia. Um, we already have that, but why do we still keep evolving? Okay, so the answer is because what we have right now are intelligent electronic systems. We have more and more of those. So these intelligent electronic systems mainly depend on the advancement of our telecommunication facilities and infrastructures. Okay, so let's try to understand them first so that uh, we'll see the connection between the two, right? And actually, intelligent electronic systems are also present in our telecommunication infrastructures. And you'll see, especially in the next subtopic, about that. Okay. So now, to get started, let's take a look at an overview of the first, second, third, and fourth industrial revolution. Okay, when we actually say electronic systems and technologies 4.0, we are referring to the EST, which is the one of the subjects of electronics engineering board exam. Okay, and when we add that term 4.0, we are actually saying that we are specifically talking about electronic systems and technologies in the fourth industrial revolution. That's why it would be nice to understand what came first. Why do we have the fourth? Of course, before we had the fourth, we have the third, the second, and then the first. Okay, so as you can see, the first industrial revolution was more on the mechanization. I think this happened sometime in the 15th, 16th, or 17th century. Okay, or even in the 18th, up to the 18th century. So mechanization, more on mechanical engineering, machines were first became widely used to do things like in agriculture, in fabrication, in daily operations of different industries. Okay, so when the second industrial revolution took place, things became faster. Okay, especially with the help of electricity, the discovery of electricity. So mass production became possible. Unlike earlier, it was not. For example, if you want a new clothing, if you want something new, you have to wait for a while. Okay, or for example, if you order 100 pieces of clothes uh, from a store, you have to wait for some weeks or maybe a month because mass production was not yet available during those days. But good thing that we have electricity. Um, the second industrial revolution took place, and uh, manufacturers were able to produce more in less time. Okay, but things became better when we had the third industrial revolution, especially in the development of. Sorry, it started with the development of semiconductor components, which led to the inception of computers. Okay, and when we already had the computers, information technology took place, and so automation. So we had our early automation as early as the 19th or the 20th century, so around mid 1900s. Okay, so when the internet was developed and more data processing have become um, found useful or being applied in different things, then we crossed the fourth industrial revolution. Okay? Digitalization became a common thing, and that's what we have right now, especially with technologies like IoT, cloud computing, robotics, and many more. Okay, so unlike in the earlier in revolution, industrial revolution, the thing that brought the revolution was something physical. In the fourth industrial revolution, it was data. And because of data, uh, we get to have more advanced systems right now. Everything becomes more and more data driven, and especially once we once we have realized the power of data. Okay, so that's a brief brief overview of the fourth industrial revolution. And okay, so we are now in the fourth industrial revolution, so that's why we have the intelligent electronic systems. Okay, so what do we mean by intelligent electronic systems? Okay, basically, we refer these systems are those that can sense their environment, communicate with other systems, process data, and naka-highlight po, make decisions, and adapt over time. So I highlighted the two things because when we say electronic systems, the earlier or the first part of the definition are actually already existing, already applicable to electronic systems. But when we add the term intelligent, then though that first part of the definition is no longer sufficient because intelligent electronic systems should be able to make decisions and adapt over time. And of course, that would be possible because of the development of AI. Okay, so here's a quick um, illustration or a brief illustration of how intelligent electronic systems work. So basically, we have the sensors, actuators, and then the user interface. So the user interface is where we communicate with the system. We as human beings, or the external agents, or the other systems as the external agents communicate via the UI. Okay, and the UI is not just operating by itself. It is powered by an intelligence core. Okay, so we have algorithms that make this whole system intelligent. Okay, so unlike before, we only have these component sensors, actuators, and then the interface. But right now, they are powered by an intelligence core, so that so that the system will be through the sensors, the system will be more able to understand its environment, plus whatever its action whatever action it implements or executes, it will be able to measure, it will be able to monitor and analyze how it affects the environment. So it's like a feedback. So it has a loop. Okay, so whenever it does something to the environment, it is aware of its impact. Okay, the system is aware of its impact. Okay, and for example, here I believe this is a camera. So the sensor component is a camera. So the system is able to sense whatever is happening to its environment. Okay, so maybe it is automating something like the air conditioning or the um, some other outputs in uh, maybe, for example, um, if it is monitoring the safety status of the environment, then it will not trigger any actuator regarding safety alarms or safety notifications or safety outputs. Okay, so but once anything goes wrong here, anything that is detected by the system, once it detects something, then it will perform some actions. Plus, it will trigger the external agents. It will notify them, um, of course, so that while there is an output already taken, the external agents will get to do their thing at the same time. Okay, so that's one way to look at the intelligent or the concept, the essence of electronic intelligent electronic system. It has um, performed a certain decision, but still it is able to inform the external agent of what has happened. Okay, so it is very important that the external agents, the users, the admins, know whatever the intelligent electronic system is doing. Okay, so that's part of us as users to, of course, to check what is happening. Okay, and whether everything's okay, whatever data that we want to get from this system. Okay, and to understand more about intelligent electronic systems, we have to um, get a glimpse of these key technological enablers. Meaning, without these components, the intelligent electronic systems will not be like what they are right now. Okay, of course, as mentioned earlier, they have to have sensors and actuators or input and output transducers. So these are components that convert physical physical quantities into electrical or electronic signals, and then vice versa. Okay, also of course that the one that's accepting the inputs and producing the outputs is the processor. Okay, sometimes it can be a microcontroller or microprocessor or even a microcomputer. Okay, so the term edge basically says that it is the it is the one closest to the field or the environment. Okay, let's say the mastermind is right here, so the edge is here. So edge is the one closest to the field or to where the action, yeah, takes place. Okay, the one that's actually in the actual scenario. Okay, and next to the edge is the fog and then the cloud. So there are three main levels of processing. Edge is on the device itself, on the field itself, or the end devices. But if the end devices, if the edge processors of these end devices cannot handle the processing, then we need we might need fog computing. Okay, the processing may take place here, but if it is of something of higher level, then it would be escalated to the cloud computing part. Okay, so why should we have edge and fog if we have we already have cloud computing? Answer is latency. So if our signals have to travel all the way to the cloud, from the end devices up to the cloud, then latency is a big problem. It will take long before we get the results, especially if the processing involves a lot of data. Okay, and if the end devices are located in areas where signal reception is a big concern. Okay, so especially if there are connectivity issues, edge processors will is our first line of defense. Okay, and next to that is the fog, and then last choice is the cloud computing. Okay, so it's nice that we understand how these things work as well. Okay, of course, for the decision making and the adaptivity features of intelligent systems, of course, they have to have some level of machine learning and or AI. Okay, so we're not going to discuss how machine learning and AI works, but we're going to see some of the use cases and how they exactly play in communication systems and other electronic systems. Okay, so for this webinar, our focus is more on the um, connectivity aspect of electronic systems and technologies. Okay, especially wireless because like this, the and devices um, they might be located far enough from their processing stations or even the master stations. So, especially if long distance is um, uh, uh, something inevitable, so wireless connectivity is our best option. Okay, although compared to wired, wireless is slower and more and less secure. When it comes to convenience and cost or economic considerations, wireless connections are still more advantageous. Okay, so when it comes to wireless connections, we have a lot of options, and we can choose among them. Usually based on their range and data rate. So data rate means how fast. Okay, so as you can see, the fastest among them is 5G. Okay, while the slowest is I think NFC and Sigfox. NFC is um, similar to RFID, built into your phones or smart devices. Okay, so in terms of range, NFC is also the lowest because it's the more most convenient one to incorporate in your smart system. And the one that has the highest is still 5G and BIoT, narrowband IoT, and Sigfox. Okay, so in terms of range, you can choose among the three, but in terms of data rate, the fastest is 5G. That's why this is where our discussion is going to or is leaning on. All right. So that's it. We have the sensors and actuators, edge processors, fog or cloud computing, machine learning and AI, and then we have the wireless connectivity. All in all, once we have this, then we can have an intelligent electronic system. Okay. So let's talk about some of the trends in intelligent electronic systems. First one is the what we call edge intelligence. So, short description, AI computation happens directly on devices, just like what I said earlier, instead of relying on the cloud, enabling real-time decisions with lower latency and improved privacy. So why improve privacy? Because remember, the more devices or signals have to go through, the more chances of getting hacked. Okay, the more chances of encountering some security issues. Okay, so if we only have a short distance between the actual device and our processing device, then we can have a lower latency and improved privacy. So for example, our smart CCTV cameras detecting intruders locally, so we don't have to send data to the cloud or to the main station just to process them, and then vice versa. But with edge computing, with edge intelligence, we can process them locally. Okay, just like AI enables sensors making instant safety decisions in factories. So the device itself can make decisions, and they do not have to wait for someone to say yes or no. Okay, they don't need another system or a user to tell them what to do. Because of edge intelligence, they themselves can make the decisions immediately when needed. Okay, another trend is the hyper automation. So um, systems combine AI, robotics, analytics, and automation tools to perform tasks with minimal human involvement from detection to execution. So hyper automation is not just all about decision making, but what can they do? Okay, so it's like a message relay. So once we get the input, we send that input to the next component. Let's say from the sensor to the processor, processor to the actuator, and then actuator will trigger a series of machines. Okay, so from detection to execution, stage one of the processing of last stage, stage two, three, four, five, and so on. So for example, we have the automated warehouse where the robots that sort, pack, and transport items without human control. So it's not that we're going to replace humans because we don't want that. Um, what we are saying is with the hyper automation, um, humans will be more productive in something else. Okay, apart from these repetitive and hazardous tasks. Okay, so that means with the help of hyper automation, our workplaces, especially automated warehouse, will become um, more productive, but at the same time safer to our workers because they don't have to do these things by their hands anymore. Okay, so of course, we are concerned with the welfare of our machines. When good thing we have the self-healing electronics or the devices and networks diagnose faults and reconfigure or repair themselves automatically, ensuring continued operation with minimal downtime. So this is somewhat like science fiction, but yes, it's happening right now. It has already started. Um, we have we we have intelligent systems already that know how to fix the detected faults in there within them. Okay, just like in Iron Man and other Marvel stuff. Okay, so for example, a communications network that reroutes traffic instantly when a link fails, or a firmware that recovers from software corruption automatically. So, isn't it amazing that the systems know what to do whenever there's problem within themselves? Okay? So instead of saying, "Oh no, I'm broken," no, they do something. Okay, they find a way, right? Like in the communications network, then they use another route. But when, for example, in embedded systems, when the firmware is affected by a certain error, which somewhat modified its code, then it can intelligently fix that a modified part. Okay, it will detect the modified part and then fix it, right? So it's nice. Also, we have the human machine collaboration, which makes our systems more friendly user friendly. Okay, so these are intelligence machines that work alongside humans, enhancing productivity, safety, and decision making rather than replacing human workers. Okay, so humans can benefit a lot from these types of machines because these machines can understand them more. So, especially with the use of NLP, natural language processing, we can directly say the machine. We can directly tell the machine to do this series of things, and they will do it, just like what we do with ChatGPT. Okay, we tell ChatGPT to perform these things, and then it will perform it. Most of the time, it's correct. Okay, of course, it's still learning. It's still a learning progress, right? So same thing with machines. So with the help of human-machine collaboration, um, we can do more. It will be more. It will be easier for us to achieve the best results possible. Okay. For example, we have collaborative robots or cobots assisting workers in manufacturing. Okay, assisting. Of course, we can assign to them the heavy stuff or the more dangerous ones, while we are more on the creative side, more on the human touch. Okay, or maybe we can have AR systems guiding technicians during repair. AR or augmented reality. We have some sort of AR glasses that helps us see more than a human eye can see. Okay, so like whatever items in front of us can have labels. We can see their status, like they are okay or need repair, like that. Okay, so it will be easier for our technicians. And another trend is the greater interoperability, or the devices and systems can connect, share data, and operate together across brands, protocols, or platforms, enabling unified ecosystems. Okay, so gone are the days that connectivity issues are brought by compatibility between different brands or different manufacturers or different designers, different programmers. Okay, so with intelligent systems, they can adjust. They can bridge the gaps between different brands, programming languages, protocols, and so on. Okay. For example, smart home devices from different companies communicating seamlessly through common IoT standards. We just need to connect to that common IoT standards, and that platform will do all the conversions. Okay. So these are some of the trends that we have with regard to intelligent electronic systems. And speaking of that, okay, a little bit of segue. We actually have the project called Safety Squared, or the status alerts and foresights on emergencies and threats to your safety. Safety squared. Okay, and this is for smart management for smart. Uh, no, no. This Safety Squared is basically intended for us to get smart management for safer spaces. Okay, I will not read the features, but basically, this is an intelligent electronic system that we are currently developing. And of course, whatever I mentioned earlier, the components, the principles, the trends are actually applicable to this project. Okay, so I'm sharing this to you. Of course, you might be interested. Let us know. We can tell you more about this project. Um, we just tell us. Okay, feel free to contact us if you want to more about this promising project. And of course, that this ends our first part. Okay, so we have some videos as we um, complete this evaluation form, quiz and evaluation form. By the way, we have 3 questions uh, included in this evaluation form. So as you fill out this form, including the quiz, you can watch these videos. Okay, you can scan the QR code or type the URL in your browser.